Alright guys, so now we're doing word problems. I like to just call them applications. Word problems sound scary, but they're not really any harder than the regular problems that we do. We're just applying them to something. So, we want to write a function rule to calculate the cost of buying X pounds of peaches if it costs $1.99 per pound. See that word per? That is really important, right? So that you know that if it was 1 pound, it'd be 1.99 times 1 pound. If it was 2 pounds, it would be 2 times 1.99. Or if it was 3 pounds, 3 times 1.99, right? So those numbers, 1, 2, and 3, those are our x's. Those are the x number of pounds. So it's 1.99 per every pound that we buy. All right, so that per, that word is going to be the indicator for what is multiplying the x. If there was a plus something over here, that would be some fixed value that never changes, right? But the cost is going to change if the number of pounds changes. So we can call that y equals 199x. Or since we have more problems to do, we could also use function notation and say c of x equals 199 times x. All right, that means the exact same thing where you just say c of x is the total cost and x equals the number of pounds. All right, piece of cake. So our second one here. Martin earns $7.50 per hour. All right, so that is going to be our multiplier for the x. He earns $7.50 per hour proofreading ads in a local newspaper. His weekly wage can be described as the equation this. W equals 7.5h, where h is the number of hours worked. Write the equation in function notation. All right, so this is really wicked easy. All you got to do is just say, instead of w, it's w of, and not x here because that's not the variable we assigned. We assigned h, so it's going to be w of h. So w of h equals 7.5h. All right, so this is just, remember, the name, and this is what we do. All right, so find f of 15, f of 20, f of 25. So what we do is we just use our calculator. All right, 7.5 times 15, 7.5 times 20, and 7.5 times 25. Okay. All right, so then there we go. Those are our values. So we found each of those. This is this one. All right, and then explain what each answer means in terms of the problem. So what each answer means is just that since we're plugging in number of hours worked, this means that Martin worked 15 hours and earned $112.50. All right, so one last example here. Christina earns $7.50 per hour babysitting. Write an algebraic expression to represent the money Christina will earn if she works H hours. So we're saying H equals the hours worked, and we're going to say how much she makes. Let's call that M for make, equals total money made. Write an algebraic expression, so we could write M equals 7.5 times H, right? Because it's 7.50 per hour. Or you could do M of H equals 7.5 H. Same exact thing. Okay. Choose 5 values for the number of hours she can babysit, create a table, and graph it. So we got, let's say, 2, 3, 4, 5, 6. Why did I start at 2? I don't know. Why not? So if she babysat for 2 hours, that would be $15. Babysat for 3 hours, that would be $22.50. Babysat for 4 hours would be $30, $37.50, and $45. Okay, so we're gonna have to adjust our scale over here because there's only 10 boxes, so we obviously can't go up to 45. Let each box count as 5, so that way we got 10, 20, 30, 40. We can fit it. Okay, so our y-axis, that's our dependent variable, how much you make depends on how long you work. So this is going to be our m-axis, and this is going to be our h-axis. And these can just count as 1. So 215, 322.50, which is there, 430, 37.50, and 6:45. All right, so we made our graph. Does it make sense to connect all the points in your graph with a line? Why or not? Why not? Well, there's a couple legitimate answers here. You can almost say yes or no. Yes, it does make sense in the fact that she could work any amount of time and technically be owed any certain amount of money. Although chances are with babysitting, you're not going to get paid for working, 3 hours, 27 minutes, and 14 seconds, right? They're going to round it to maybe the nearest half hour. All right, so either you could round it to the nearest half hours and plot those points too, or you could just assume that you're babysitting for some nice people and they're going to always round up to the next hour and just keep these. Right? So it probably, in this situation, doesn't really make sense because I doubt that you can get every single dollar amount in between. All right? Chances are someone's not going to make change for 3 hours, 12 minutes, and 47 seconds or something like that. So we're going to go with a no. And then you have to have listened to this to understand why. All right, so here's your U-try, and see you next class.